Hi, Ashish Rastogi here again with Math115.com doing another video, but this time we're doing continuously compounded interest. So just like the discrete compounding interest, the continuous ones have their own formulas to use. So continuous means that there is interest that is being compounded every moment of every single day, continuously for whatever duration. So this is the future value formula. You can remember it as future value is equal to PERT, P-E, raised to the RT. You have your effective annual yield formula right here, a lot simpler than the discrete one. And same thing with your rate formula, a lot simpler than your discrete formula for rate, interest rate. So let's go ahead and go here, and you notice that this time there is no n, right? That means that the n does not apply because it's continuous. N refers to the number of compounding intervals. Well, continuous compounding means that there is going to be an infinite number of compounding intervals, so you don't even bother with n. So let's go ahead and go straight into a problem. So let's say you have a situation where you're asked, what is the value of $47,500 after 3 years and 8 months if it is invested at a rate of 6.05% compounded continuously? And then what is the yield on this investment? So let's first find the value and then we'll calculate the yield. So first thing we need to do is we need to find out what is the future value of this investment going to be. So the future value formula will be this. F is equal to P E raised to the RT. We know that the future value is what we're looking for, so it's a variable, but the present value they said was $47,500. E raised to the R, they said R was 0.05%, so as a decimal, that's 0.0605. And they said 3 years and 8 months. So what that is going to be is it's going to be 3 years plus 8 over 12. And if you recall, 8 over 12 is the same thing as 2/3, which is the same thing as 0.666 repeating. And we'll throw another 6 on there to be politically correct. So now we just need to solve this formula. If you throw this into a calculator, you can do it exactly like this. If you use your parentheses, you'll want a parentheses right here, another one at the end, you'll want a parentheses right here, and another one right here, and you should be good. So if you plug it in exactly like I have here, with the parentheses that I have here, your calculator should get you the right answer, and in this case, the answer for this is $59,297. $59,297. And let's go ahead and get the cents. The cents are 26 cents. There you go. So $59,297.26. So the second part of that question was, what is the effective annual yield? What is the yield for this investment? So the way that this will work is you do need to use the yield formula. So again, we'll use this formula right here, y equals E raised to the R minus 1. We're trying to solve for the yield. So R, they told us, was 0.0605 minus 1. So yield is equal to, and what you should get is 0.0624, I'm pretty sure. Yes. And so that is the same thing as 6.24%. So why is this yield percent number different than the this number right here, the 6.05%? The reason why this number is higher is because what happens when you compound interest, let's say you have $1, right? And you earn another $1 of interest. Well, if you earn 100% interest, right, that you now have $2 from that first set of interest, and now the next compound will take 100% of the existing amount. So now you take 100% of $2 and you get $4. So what happens is the compounding interest is also earning interest on the interest that you've already accrued, and that causes the effective actual interest to go up. So that's kind of what effective annual yield means, is that what is the actual yield of interest that you're going to get, which is different than the actual percent interest. That's why when you go to a bank, they always say that your APR is this, but your effective APR, or your effective interest rate, is something different. That's what they mean by that. And that's how you do continuously compounding interest.